Comfortable with the grade line. Okay. So to how many carbons it is directly connected? So very simple it is. If I'm going to show you, this is your amine, RNH. So you can see N is nitrogen, NH2 is amine, and R is alkyl group, one carbon or any other carbon. That means this nitrogen is connected with only one carbon directly. So this will be known as primary amine. The way we calculate the degree of carbon, in the same way we calculate the degree of amine. Then comes your one hydrogen is one more hydrogen is replaced with this. So you can write like this: CH3, CH2, and then NH, and then comes your CH3. So you can see this nitrogen is directly connected with two carbon. So it is secondary amine. It is secondary amine or 2 degree. In the same way, if all the hydrogen is replaced by alkyl group, this alkyl group may or may not be different. That depends upon the compound. So you can see that this nitrogen is connected with how many carbon? 3 carbon directly. So it is tertiary amine. Are you getting my point? Or we call it.
Yes.
So this is how the amine classification takes place. And always remember that these are all amine, but they are treated as different functional group. Let me know when you are done with this.
Yeah, done, sir.
Or you can write a point: primary, secondary, and tertiary. Amines are treated as. They are basically different functional groups. If you are going for the structure, let's say tertiary amine for a structure, you are going for, let's say this is your CH. Three bond nitrogen will make, and you know that there will be a lone pair. So if you are going to see the hybridization is sp3. So geometry will be tetrahedral. But when you are going to see the structure, since lone pair is there, so there will be a repulsion, and hence the structure will be pyramidal, like in NH3. Classification already did. I did primary, secondary, tertiary. Then we will go for nomenclature.
Yeah, done, sir.
Are you done with this?
Yes, sir.
Okay, Austin, we just started amines. So first we studied degree of amines. Am I audible, Austin?
Yes,
Degree of amines means you are going to treat nitrogen as carbon. To how many carbons N is connected, amine is connected, or nitrogen is connected? Like N is connected to only one carbon. So this is your primary amine. N is connected. Now one of another other hydrogen is replaced by R. So this is directly connected to two carbons, so it is secondary. In the same way, this is your tertiary or 3-degree amines. And this, please take a screenshot and let me know. And this primary, secondary, and tertiary amines are treated as different functional group. Plus, this is the structure of amine. If you are going for take another NH3 or NH2, basically primary, secondary, tertiary, the hybridization comes out to be sp3, which means the geometry should be the geometry is sp tetrahedral, but due to the presence of lone pair, there will be more repulsion and the structure becomes pyramidal. Please take a screenshot. Done. Okay. Now moving to the next part, that is nomenclature. So see in nomenclature, IUPAC nomenclature, what we do is very simple. IUPAC is equal to basically alkane plus amine. Alkane amine we call it alkane plus amine. That means if there is any substituent, I will tell you how to write. So this is IUPAC comes out to be. Let's say if you have CH3, CH2, NH2. So only one carbon chain is there, so there is no problem. And you can see this has two carbon in the parent chain. So two carbon, that means eth, and they are singly bonded. So ethane and amine is there. So you are going to write ethane amine. This is how we are going to write the IUPAC of primary or 1 degree. If you have something like this, NH and this, that means you can see there is only one carbon on the right hand side and there is two carbon on the left hand side. So I think you can easily decide which one will be parent chain and which one will be the substituent. So this will be your substituent because it has lesser number of carbon. So how we are going to write? You know that this is your methyl since we are going to use as a substituent, it is methyl. So what will be the numbering? In amine, what we do in numbering is very simple. N-methyl, that represents basically this methyl is directly connected to NH or N. So N-methyl, and then comes your this parent chain which has two carbon, that means it, and they are singly bonded. So ethane, and it is amine. So this is how we are going to write. Is that clear, Kumam?
Yes, sir.
And if you have something like this, let's say this and this, so you can see you have this is your secondary 2 degree, and this is your primary, and this is your tertiary. So you can see there is methyl, and there is ethyl. So you know only one chain will be the parent chain. So this will be the parent chain. The rest will be your substituent. And methyl is there, so you are not going to write and methyl. If you have two methyl, like on the second position and third position, so how you are going to name it? 2, 3 dimethyl. So in the same way, since this methyl is connected to the same nitrogen, so you are going to write N dimethyl, and then come to the parent chain. How many carbon is there? 2. So if and singly bonded ethane amine. Is that clear?
Yes.
If you have something like this, let's say something like this, just wait a minute. Now, you know that this is 2 carbon, this is 1 carbon, and this is 3 carbon, which is the parent, this is the parent. The rest is your substituent. So this is your methyl, this is your ethyl. We always write the IUPAC in alphabetical order. So you are going to write N-ethyl, then N-methyl. How many carbon in the parent chain? 3. So prop and singly bonded propane. Amin. Are you getting my point?
Yes.
Right. I will give some question, then we will move to the next part. Let me know when you are done with this.
Done, sir.
Austin, no. So this question you don't need to write. You just need to tell me the degree with the question number, part one, two, three. The rest I'm going to write. This is IUPSC you are going to write. Oh, look at the third question, Austin again. Very good. Oh, it's correct. I got confused. Very good, Austin. Come on. So 1 degree, very good, Austin. Then it becomes tertiary. Second one, very good. Then third is primary, very good. And the fourth is secondary, right, everyone? Both of you?
Yes, sir.
Now, moving to this, you need to write the IUPAC of all this. Wait, I'm giving you 5 minutes for this. Let me know if you are done with this. Any answer? Are you able to solve it? Okay, very good. Third one, Austin, how many carbon? On one side, four carbon is there, I think, and on another side we have three carbon, right? Very good, very good, very good. Generally, we don't use para, ortho, and nitro in IUPAC. We write number. Okay, so take care of this. Very good. Mom, what about you?
Solving, sir. One.
Okay. Okay, I'm going to explain now. So see, this is your 1 degree amine, so you can number it from here so that it will get lowest position. So what its name will be? Bute and single bond, so butane, 2 amine. Now for this you can see there is one carbon, there is one carbon, and only one carbon, one carbon is there. So you have to take one of them as a parent chain. So I'm going to take this. The both this will be treated as substituent. So its name will be something like N comma N dimethyl methanamine, right? N comma N dimethyl methanamine. Okay, you also did. Butane, 2amine, very good. First one you did. The second, third you didn't. Fourth is but. No, no, no. You are talking about this. Umami, there is only one
Yes.
three carbon, so not but. It will be prop 2 in 1 amine or prop 2 amine in amine. You can write like this. Are you getting my point?
Yes, sir.
Second is dialkyl. Alkyl is what? You have to write dimethyl and you have to write N comma N dimethyl and dimethyl methanamine. Got it?
Yes.
Fifth one, if you are going for fifth one, there is six carbon. So on the first carbon there is amine, on the sixth carbon there is amine, and there is no branch, so there will be hexane 1,6 diamine. Then no, there is no methyl in that. Sixth is benzenamine, not benjamine. Sixth is where there is it's wait a minute. What's this? This is your benzene amine, which is also known as aniline, which is a common name, but now it is used as IUPAC. and this will be 1, 2. So this will be cyclomethyl. Hmm. This is your benzene, and this is your substituent. So what it will be? Very simple. 2-methyl. Either you can write benzenamine, or either you can write 2-methylaniline. Okay, and this you can write 1, 2, 3, 4. So 4-bromo-aniline you can write, because this whole part is your aniline. So you can write 4-bromo-aniline, or you can write 4-bromo-benzenamine. 4-bromo-benzenamine. Are you getting my point, both of you? After this CH3 is twice. This CH3 is twice like this. That means very simple. This is your branch, and this is also your branch, because we have this as a main parent group. So N comma N dimethyl benzenamine. Is that clear? And this one you can see the three. This will be your branch, and this will be your parent chain. So we can write propyl N propyl, or propyl butanamine. Is that clear? You can write N propyl butanamine. I think it's clear to both of you, right? Homa.
Yes.
Okay. So please do write it. If there is any confusion, you can ask me. Benzene will be benzene. It will never be cyclo or something like that. Now we are going for methods of preparation of amines. Methods of preparation of amine. Just wait a minute. So the first method comes out to be very simple, and that is reduction of nitro compounds. Reduction of nitro compounds. So very simple it is. In this is your nitrobenzene that I'm going to take. Nitrobenzene. And you are going to use H2 in the presence of PD, palladium, and ethanol. So basically, this is a reducing agent, so it will reduce this compound easily, and it will reduce into this oxygen will be replaced by hydrogen, and you will get aniline. You will get aniline. Either you can go through this, or the second method is with the same reactant. You can see this is your nitrobenzene again, and here you can use SN 10 plus HCl, 10 plus HCl, or either you can use Fe plus HCl. And this is also going to act as a reducing agent, and you will be getting again aniline. So aniline, just wait a minute. Aniline is basically common name of benzenamine. Now it is treated as IUPAC. I think it's clear to both of you, right? So this is the scene. Okay. And in this method is preferred. This method is preferred. Why it is preferred? So basically, the FeCl2 formed after reaction on hydrolysis, you will get HCl. So I'm going to write a small point here. The rest you can write. Reduction with iron and hydrochloric acid. FeCl form gets hydrolyzed to release hydrochloric acid HCl during the reaction. Let me know when you are done with this. Are you done with this? Umam?
Yes, sir. Done.
Very good. Now the next method is ammonolysis of alkyl halides. So basically, what is ammonolysis? I will explain this. Very simple it is. Before that, ammonia is there. If ammonia is there and it is going to react with alkyl halide. You know that alkyl halide, halogen are living group. So what it will do? It will attract electron, take electron from alkyl group. So there will be deficiency of electron in R. So this will be attacking on this. So basically what will happen since this will give it, so it will be RNH3 positive, yes or no? Since nitrogen donated its electron, so there will be positive charge and this will be the bond between nitrogen and R will be coordinate bond. But at the same time, X will be in negative, which took the electron from R. So there will be, just wait. So there will be an ionic bond between this NH3 positive and X negative. And we call it substituted or alkyl substituted. That means you can say for R, ammonium salt. Ammonium salt. See how the reaction is going to proceed. Very simple it is. If you have 1 degree amine, RNH2, and you are going to react this with Rx, you know what will happen and what is going to be formed. Very simple it is. It will be uh, X negative will go, and here hydrogen is there, in which hydrogen will be going like this. So this will be going with this, so it becomes R2NH. R2NH. X is the living group, R becomes positive. Basically, you can do like this as well. There is negative, there is positive. There is positive, there is negative. So opposite charges attract each other, so it becomes this. Again, Rx is in excess. Just wait a minute. Now it's going. Now see, this Rx is in excess. Again, what will happen? Very simple. This hydrogen again is going to have positive. This is negative, negative, positive. It will be going like this. This will take its electron. So it becomes R3N, right? R3N, and HX will be released. Here the byproduct will be HX. Here the byproduct will be HX. And you can see again Rx will come into play. So, but here when it is going to move from here, it will be like this, and this will be attacking on this. So that will form R3N positive X negative. And this is your quaternary ammonium salt. Quaternary ammonium salt. So this is your 3 degree, this is your 2 degree, and this is your 1 degree. Write the reaction. And this is basically the process we are going to cleave the bond between CX. Okay, that is called with the help of this ammonia, that is called ammonolysis. Let me know when you are done with this. Just wait a minute. Are you done with this?
Yes, sir.
No, sir. Very simple it is. You can regenerate this primary amine again. How? So very simple. When you are going to react this quaternary ammonium salt, so not quaternary ammonium salt, this NH3 positive, the salt that we made. If you are going to dip this in NaOH, then you will be getting RNH2, primary amine. Okay, plus H2O plus NX. Basically, what happens when you are going to react ammonia with alkyl halide, you will be getting substituted ammonium salt. And this substituted ammonium salt is going to treat with sodium hydroxide and you will be getting 1 degree amine. After 1 degree amine, again you are going to react with RH, 2 degree amine you will get, again RH, 3 degree amine you will get, again RH, 4 degree or quaternary ammonium salt you will get. But the best product will be your 1 degree because this is the major product that you will get. After that, you know that 100% efficiency is nothing like that. So major product will be 1 degree. Is that clear?
Yes.
No. So please do write it. Let me know when you are done with this. Both of you are done with this.
Yes, sir.
Now the next method, third method, comes out to be reduction of nitriles. Nitriles is basically cyanide we are talking about. So this is your cyanide. And when you are going to react this with H2 in the presence of negative, or either you can use sodium amalgam C2H5OH. So basically what will happen very simple it is RC triple bond N. Hydrogen will be there, hydrogen will be there, hydrogen will be there, hydrogen will be there. So it becomes RCH2NH2. So if I'm going to give you a question like this, CN, and you can use any one of them. So what is the name of the product? Are you done with this?
Yes, sir.
So what is the name? So you can see 1, 2, 3, 4. So it will become something like this. So it will be butanamine, right?
Yes,
Now after this, we have another methods of preparation, and that is the fourth one, reduction of amides. This is also easy. Reduction of amides. So very simple it is. Amide, RC double bond O NH2. This is your amide. And we are going to use lithium aluminum hydride, which is a strong reducing agent, followed by hydrolysis. So very simple things is going to happen. This bond will be broken, hydrogen will be added here, hydrogen will be added here. Then this will be broken, hydrogen will be added here, hydrogen will be added here. And you will be getting RCH2, NH2, and water will also be there. Let me know when you are done with this.
learn, sir.
Now the next one is the fifth one, Gabriel Thalamide synthesis. Or the compound will look bigger, but the product, the main product is quite a smaller. We will take 1 degree amine. So see, we are going to use Thalamide. Just wait a minute, it's so big. This is your thaliamide. We're going to react this with KOH, which is a strong base. And what will happen? This hydrogen will be replaced by K, and the rest part will be as it is. The rest part will be as it is, and K comes here, which is positive because it is a metal, and nitrogen will have negative. After this, you are going to react this with alkyl halide Rx. Now, what will happen? X will have negative and R will have positive. Again, what is the scenario going to happen? X will have negative and R will have positive. So you know what is going to be happen. This negative positive will be attraction takes place, negative positive, and with N R will go, and this K and X combine to form a salt KX. Okay, and this is a name. There is O and there is O as well. N alkyl phthalimide. N alkyl phthalimide. After this, you are going to react this with a strong base. I'm going to show you. So a strong base you are going to use. Double bond O is there. So after this, you are going to use NaOH in aqueous solution. So this bond will be broken, and this bond will also be broken. And this will be converted into something like this. O negative and Na positive will come. O negative and Na positive will come, along with the formation of RH, 1 degree or primary. And we generally use this Gabriel thalamide to produce this. Very simple it is. After dipping into aqueous NaOH, this will be broken, this will be broken, and OH negative H will be replaced by Na+. This will be right. Are you done with this?
Yes.
The next is the sixth one. Hoffman bromamide degradation reacts. So see degradation from the name, you can see there will be some decrement in the carbon chain. Very simple it is. If you are going to react amide with Br2 in the presence of NaOH, to balance, I'm going to take 4 moles of NaOH. Now, what will happen is very important. This whole carbonyl group will be eliminated and it becomes RNH2. RNH2. This CO will be going with sodium and it becomes Na2CO3 along with NaBr and H2. And this is Hoffman bromamide degradation reaction, very important it is. Please write the main product.